And then 13b, find the equation of the tangent and the normal to the curve given by f of x equals to 5x cubed minus 7x squared plus 3x plus 1 at the point 1 and 3. So we are given this question, and that we should find the equation of the tangent and the equation of the normal to this curve at a point 1 and 3. So what do we do? Remember we said for us to get the equation of the tangent and the equation of the normal, we need to get the derivative of the curve or the gradient function of the curve. So we differentiate the given equation of the curve such that we find the gradient function of the curve. It will help us. So since we are given function f of x, we can say the derivative f prime of x, this is the derivative or the gradient function of this curve, equals to, then we differentiate this using the law of powers and coefficients. When we lower 3, we shall have 5 times 3, right, x. Then we subtract 1 from the whole power, so 3 minus 1 gives us 2. Then we have minus 7 times, we drop the power, times 2, x. We subtract 1, 2 minus 1 is 1, so this is to power 1. And then plus, the same, we shall have 3 times 1, x here, x is to power 1 here, but if we subtract 1, this is to power 0. And then plus, if we differentiate a constant, we get 0, simply because derivative is the rate, it gives us basically the rate of change. It gives us how fast the function changes when the variable changes. But here now the variable is x, and the constant 1 is independent of x, so it is not affected by change in x. That is basically what we mean when we say differentiating a constant gives 0. And then here we simplify. We shall get 15x squared here minus 14x plus 3, because x to the power 0 is 1, 1 times 3 is 3. So this is the derivative of that given function. A reminder, this is Vision Plus, and if these materials are important to you, then share them with your friends, share them with students, and share them with your classmates. Let us continue. So this is the gradient function of the curve, and remember, this is the same as dy dx. Okay, it is the same as dy dx, simply because f prime of x is the first derivative dy dx, so we can use them interchangeably. So after getting the derivative, now this is the derivative of the curve. What is the importance of derivative? It gives us the gradient of the curve at a given point. So if this is the gradient function of the curve, we can use the point 1 and 3. This point 1 and 3 is on the curve, and to sketch it quickly, assuming this is our curve, it can be, assuming this is the curve, it can be in any manner, this is not accurate, and then the tangent touches the curve at one point like this, at one point like that. Use a ruler, I'm struggling to draw because I'm using freehand. This is the tangent, and then the normal to the curve is perpendicular to the tangent, something like that. So this is the point, this point where they're all meeting, point 1 and 3, that is the point of tangency. This is a point where the curve, the tangent, and the normal, this is the normal, are meeting. So this point is on the curve. So what I want to do is, I want to find the gradient of the curve at point 1 and 3. So at point 1 and 3, the gradient of the curve, which is dy dx at the point 1 and 3, becomes, where this is x, remember this is y, so where there is x, we put 1, so we shall have 15, x is 1 squared minus 14, x is 1, and then plus 3, and then we press the calculator. So here we shall have 15 minus 14 plus 3. So here I'm getting 4. Okay, so this 4 is the gradient of the curve at the point 1 and 3. Now, what is the connection between the gradient of the curve and the tangent? That is still here. Now, at the point of tangency 1 and 3, the gradient of the curve is the same as the gradient of the tangent. At the point of tangency 1 and 3, the gradient of the curve is the same as the gradient of the tangent, not the normal. So therefore, we can say the gradient of the tangent is 4, because they are the same with that of the curve at the point of tangency. So now we have the gradient of the tangent 4. Now, remember, a tangent is a line. And if we know the tangent, a tangent is a line, and if we know the gradient of a line and one point on that line, then we can find the equation of that line. So this is the gradient of the tangent, and the tangent passes through this point of tangency 1 and 3. So we have the gradient of the line, which is a tangent, and then the point on that line, which is a tangent. So we can find the equation of that tangent using the equation of straight line y equals to mx plus c. So this is our x1, so this is our x, and this is our y. So we substitute, our y is 3 equals to our m is the gradient. This is the gradient m times x is 1 plus c. Then we make c the subject of the formula. So c is a -1. After getting c, I believe you know how to use the equation of a straight line. So after getting c, then our equation of the tangent becomes y equals to, substitute for m, which is 4, x plus c, but c is a -1, so -1. So this is our equation of the tangent. Equation of the tangent. Now, how do we get the equation of the normal? Remember, the normal is perpendicular to the tangent. Therefore, the normal and the tangent are perpendicular lines. So the normal is perpendicular to the tangent. And what do you know about perpendicular lines? If the normal has a gradient, call it m1, and then the tangent has a gradient, call it m2, how you name them doesn't matter. Then the law says the product of the gradients of two perpendicular lines is -1. So m1 times m2 is supposed to give us a -1. But we have said m2 is the gradient of the tangent, which is 4, which is here, which is 4. How you name them doesn't matter. You can call this m2 and this m1. It makes no difference. So our m2, which is the gradient of the tangent, was 4. So we can substitute for it here. m1 times m2, which is a -4, which is 4, sorry, which is 4, it gives us 4m1 equals to -1. Therefore, m1 equals to -1 out of 4. This is now the gradient of the normal. This is gradient of the normal. Yeah, we are taking time, but these are the steps of the normal. So after getting the gradient of the normal, then we need to find the equation of the normal. Remember, a normal is a straight line. And if we know the gradient of a line, like m1 here, and we know one point on that line, because this normal continues down like this. So we know one point on the line, which is point 1 and 3. That is a common point to the curve, to the tangent and the normal. So we have the gradient m1, and then we have a point on the normal, which is point 13, I think, 13, yes, point 1 and 3. Then we can apply the equation of a straight line, that y equals to mx plus c. If you don't know about the equation of a straight line, visit our list of videos in Senior 1 Mathematics, Senior 2 rather. So this is our x, this is y. Then we substitute. Our y is 3 equals to our m is -1 out of 4. Our x is 1 plus c. And then you make c the subject of the formula. I'm going to press my calculator and get the value of c. You can follow your normal steps and get c. So see, I'm getting 13 out of 4. So since we have, now let me first write the equation. Since we have c and m, then we can write our equation. So the equation becomes y equals to m. Our m is the gradient -1 out of 4, x plus c. Our c is 13 out of 4. And therefore, this is our equation of the normal to that curve. Equation of the normal. So we have come to the end of example 13 of number 13b. It has taken time, but this question was long. I have explained, and in case you want more videos and lessons on the normals and the tangents to curves, then visit our list of videos in differentiation. Otherwise, thank you.